Next, let's discuss regular expressions. So regular expressions lets you describe patterns and then match against those patterns. Unlike Java, if you're familiar with regular expressions in Java, in Ruby, regular expression is not a string, it's an actual, its own data type. The way you use it is you use this equals and a tilde to see if a pattern matches a string, and it's ambidextrous, which means you could have a string on the left side, or you could have a string on the right side and the regular expression on the other side to match it. If you want to add case insensitivity, you specify the I as a flag after the regular expression. So for example, you have a string, pretty cool stuff, ABC123, and you could see if that string matches a regular expression pattern called cool. So this is just a very generic regular expression, COOL, nothing fancy here. And you could also say ABC regular expression, does that match a string A? So it's ambidextrous. And in this case, it's going to be 18 because ABC is on the 18th character, 18th position in the string. Then let's say you want to see if the string pretty cool stuff ABC123 matches a regular expression JHU. It does not. When the match does not occur, you get a nil. Okay, let's see some more examples. Let's say you have B string, cool stuff, and it's not, so it's the C is lowercase, but OO is uppercase. So pattern 1 is cool regular, and pattern 2 is cool with a case insensitive flag, I, for case insensitive. So B would not match pattern 1 because it doesn't check for case insensitivity, but it would match pattern 2, and it would match it at position 0. And I'm showing here that it works both ways. You could have a pattern on the left, a pattern on the right. It'll give you the same result. Now, some characters in regular expressions are special. For example, a dot matches any one character. Now, so far, we've only discussed matching one character, but how do you match more than one character? So if you have a question mark at the end of a pattern, that matches 0 or 1 characters of a preceding pattern. If you have plus, that matches 1 or more. If you have a star, that matches 0 or more. And then you could specify the exact number. So for example, you could say, I want a pattern that matches the exact number of times. Or you could specify minimum number of times, minimum and maximum, or just maximum. And you just leave the other value out. So for example, and this one has just minimum but no maximum, and this one has just maximum but no minimum. And the backslash allows you to escape a special character. The other thing you could do is you could have a set. So if you don't want to specify every single character in a certain set, you could just say ABC123, and this basically says one of these 6 characters. Or you could have a range, right, X through Y, which is in this case not a good example because X is right next to Y, but you could specify, for example, A through C, or 1 through 3. So in this case, you have a set of 2 ranges. So either characters A through C or characters 1 through 3 would match as part of a set in this regular expression. And we'll see some examples in a minute. You could also specify a pipe or an OR symbol, so this pattern or that pattern should match. You also have special character classes. So in this case, W means any backslash W means any letter, digit, or underscore, and the uppercase W means anything that the lowercase w does not match, the uppercase W would match. D is for digit, so backslash D is digit, and uppercase D is anything that the lowercase d does not match. Lowercase s is white space, spaces, tabs, new lines, and the uppercase s is anything that the lowercase s does not match. So let's see some examples here. For example, you have an email address, rubyclass@gmail.com, and that matches this pattern of any character that's repeated many times. So this is 0 or more times, followed by an @ symbol, which in this case is true, followed by some word, gmail.com. And that does match, and it matches at the 0th place. In this case, we're trying to match exactly 2 letters O. So nice book, in this case, 0, 1, 2, 3, 4, 5, 6. The 6th place is where the pattern would match, the 2 O's. Let's say you want to match an HTML element. So the HTML element pattern would be open and then close. Now, what this means is that you could have a slash with a question mark, which means that this slash doesn't always appear, right? Because in the open HTML element, you will not have a slash, and in the closed HTML element, you would have a slash. So both P and the closing P would match at the 0th position. Let's see some more examples. Let's say you want to have Dr. Jones or Mr. Jones. In this case, the issue is that the dot is usually a special character, so you have to escape it by having a backslash dot. And that would match Mr. Or Doctor with a dot. Next example is this or that pattern. So let's say you have a regular expression that's this or that. So this would match, that would match. Doesn't matter if it's what side of the equals tilde you're on, and it will always match at the 0th position. In this case, you want to match Mr. or Doctor. So let's say it's some kind of an important pattern, right? So you have a set of a letter D or M, and it's case insensitive, followed by the letter R, and that would match if it's Doctor or Mr. Let's say you want to see if a pattern matches a social security number. So you have a string to check, and the social security pattern is 0 through 9. You also could have used a \D for digit that repeats itself 3 times, and then followed by a dash, and then a digit with two more digits, followed by another dash, and 2 more digits after that. And you could see if that matches. Now the match will either give you a 0 or position, let's say 0, or nil if it doesn't match. So you could use the double bang to convert that to a true or false. So in this case, matches social 1, 2, 3, 4, 5, 6, 7 does not match because there are no dashes in between. But the second one, 1, 2, 3, dash 4, 5, dash 6, 7 does match. Also notice how matches social has a question mark in the method name, which makes it very descriptive. Now, so far we spoke about matching, but another thing you could do with regular expressions, you could extract values from using a regular expression. And this can be done by using something called capture groups and the match method. And when you do this, and we're going to see an example in a minute, the way it works is that you call the match on the expression, and match returns an array. The first element or the 0th element of a result is going to be the full match, and then the following elements in the array are going to be what the extraction groups, the capture groups. So for example, you have an address, 1000 Test Road, Columbia, Maryland, 21211, some kind of a fake address. And your city-state pattern is comma followed by many spaces, and then you have the word followed by another space, and then another word followed by another space. And these words here are surrounded by parentheses. So that makes it a captcha group. So if you have some kind of a bogus address, and you call the match method on it using the city-state pattern, that will give you nothing because bogus address string does not match this pattern. But let's say you have a real address that you call match on with a city-state pattern, that actually would match because basically you have comma right here, then you have space, then you have Columbia, which matches this \W, and then you have more spaces right here, and then you have MD, which is the state, followed by space right here. So the zeroth element in the array that gets returned, which is this, is going to be the full match, but then the city is going to be good result 1, so that's the first captcha group right here, and then the state is going to be the second captcha group right here. So then you have these variables that you extracted using your captcha group, and you could say you live in the city, which is located in the state. Now you could do something similar using what's called Perl style regular expression, and this is something that Ruby obviously borrowed from Perl. Instead of having actual variables, when you have a match, so address and the city-state pattern, Ruby automatically creates these global variables, the $1 and $2, instead of what we had here, good result 1 and good result 2, them being part of an array. Ruby actually creates global variables $1, $2, and so on. I don't recommend using this the regular expressions this way because it involves using global variables, and global variables, as we all know, is not a good thing to have in the language. Ruby officially doesn't recommend using them, but for people, I guess, who are used to using Perl-style regular expressions, this does exist in the language. So now the example here from Java, how to use regular expressions. So Java also allows you to use regular expressions, but in Java, the regular expression is really not its own type, it's a string. So the problem with that is, for example, you want to have a regular expression of a digit, which is \d. A string doesn't allow you to have backslash. So you have to escape the backslash with another backslash. So regular expressions are already complicated, and this just overcomplicates that even more. So now you have to have a pattern that's \d. And then when you match it one character at a time. So let's say in this case, you want to find out how many digits are in this string. So you would have to keep on matching it one at a time and incrementing the number of digits that you find, and you're going to find that this has 1, 2, 3 digits. In Ruby, you could use something called scan. So you could say, so test is the actual string, and then you could say scan this string for -d regular expression, and it's going to give you an array of all the matches. So you could see that this array has 3 elements in it, so you'll know that this expression, this string has 3 digits. Another cool feature that involves regular expressions is an array, which we haven't talked about arrays too much yet, but we'll see them in a few minutes. Array has a method called grep, which is grep is a Unix command that lets you search for things. So you could say, if I have this array, grep that array for regular expression Joe and John, case insensitive. So in this case, it will find Joe Smith and John Doe. It's pretty cool. If you're just starting out with regular expressions, or if you just want some help with regular expressions, there is a website called rubular.com, which lets you try out with regular expressions. So basically what you do is you have your test string down here, in this case lorem ipsum, and then you specify your regular expression in this text field right here, including the flags, which in this case is -I for case insensitive. And it also gives you a whole bunch of quick reference stuff on the bottom. That's very useful to remind you how things are used. And then it shows you exactly what is being matched. Pretty cool.